Okay, so today we want to talk about limits. It starts off chapter 2, and we're just going to look at how to graphically describe those. Okay, now, something that we've always done with functions is we've evaluated them for a certain x value, correct? So if I have this function, a piecewise function, y equals f of x is its name, I can evaluate points on this graph by saying things like, what's f of 5? Well, if we look, 1, 2, 3, 4, 5. Right? At 5, there's an open circle and a closed circle, and we know that to evaluate it, you would use the closed circle, correct? So in this case, f of 5 would be 4. Or, say I have f of negative 2. So if I go to negative 2, there's just an open circle. There's no closed circle. So what that tells us is that that's going to be undefined. So that's how we've evaluated functions. And this is actually what is the value when we get there. Okay, but we're going to talk about limits today. And the limit is we're going to approach the value from either the left or the right, and we're going to say what number are we approaching. So limits will let us evaluate. It'll help us sometimes deal with things like this undefined. It'll still give us an idea of what the value would be if there were a point there. So we have two types of limits. We have one-sided limits and two-sided limits. We're going to talk about one-sided limits first. Okay, so an example of what a one-sided limit would look like is what's the limit as x approaches 1 from the right of f of x. So that would be, well, here, a bunch of things go on here. LIM means we're taking a limit. You need to have that there. And this says x approaches 1, but then it has a plus sign up where the exponent would go. And this means, so it would be the limit as x approaches 1 from the right of f of x. So if you see a little plus up there, it means you're going to come from a little bit more positive than 1. So you're coming from the right and you're approaching 1. So in terms of the x-axis, right, you're coming from out here and you're approaching 1. Does that make sense? So if we take a point out here, like a point up here, as we approach this, go back, and as we approach this, we see that it approaches here. So this limit of f of x as x approaches 1 from the right would actually approach this open circle right here. We're not getting all the way there. We're not just evaluating the number. But here what we would say is this limit would be 1, because that's the y value that the function approaches as we approach, that it gets close to as we approach 1 from the left, or the right. So then with that, we'd say what's the limit as x approaches 1 from the left of f of x? And again, you have to have the function name in there or else it doesn't really mean anything. You have to have where the limit's going. You have to have where it's, whether it's left or right if you're doing a one-sided limit. So take a second to look at that, but as we approach 1 from the left, so start somewhere to the left of 1 and then approach, you don't get super far. You would be on the same piece of the function. But if you start here and we go to the left or to the right, as we approach, we're coming from the left and we're approaching 1, you see that it approaches this point right here? So that limit would be 1, 2, 3, 4. So what this is showing us here is the left-hand limit at 1, we approach from the left, gives us an output of 4, and the right-hand limit, as we approach 1 from the right, gives us an output of 1. Okay, so let me, okay, so with our same graph here, a couple more one-sided limits, but this is telling us f of x is the name of the function, which is our graph over there. This is saying as we approach 5 from the left. It's got the little negative up there. It's a left-hand limit. It's a left-hand limit. So 5 is right here, correct? So the curve to the left of it is this piece right here, isn't it? So as we approach 5 from the left, it brings us right to this closed point, doesn't it? So that closed point has a y value of 1. So we'd say the left-hand limit, or we could say the limit of f of x as we approach 5 from the left is going to be positive 1. So then this is the next limit we want to do. This is the limit of f of x as x approaches 5 from the right. So for this one, you'll still start at 5, but you want to go a little bit to the right of it and then approach that point. Well, if you do that, it puts you up here, doesn't it? And you approach that point. So that would be 4. It's just that. So again, this means coming from the left, and that means coming from the right. Is a left-hand and a right-hand limit. They're both one-sided limits. We also have some other, you could also do, here a couple more. Try the limit as x approaches 2 from the left of f of x, and the limit as x approaches 2 from the right of f of x. About the limit as x approaches 4 from the left of f of x, and the limit as x approaches 4 from the right of f of x. So take a couple minutes, using this picture, go ahead and try to evaluate those limits. All right, so looking at these, this is, and again, it helps to just read them and know what they're asking. This would be, as we're approaching 2 from the left, correct? Saying, what does the function go? Did I say 2? No, it's still worthwhile to look at. But at 2, it's just this point right here, isn't it? Which is a bad example because it doesn't really have a nice value. But let's say it's, I guess I'll do it. Let's say it's about 1.3 maybe, right? But would it approach the same point from left and right? Sure, so let's say it was 1.3 and 1.3. If you ever have to do a limit where it's just on a continuous line, both sides should be the same, the left and the right hand. Do you guys know I meant to do -2 and I just forgot to put the negative sign there, but we'll do it in a second. How about f of x, the limit of f of x as we approach 4 from the left? Now what's happening at 4? There's a vertical asymptote, right? But as we approach from the left, our y values are going to get bigger and bigger and bigger, and they're going to approach infinity. And then as we go to 4 from the right, so here's 4, we're going to come from the right. We see the curve drops down, and that's going to be negative infinity. And then here, the one I really wanted to have you do here, let's fix this. What would it be of -2 from the left and -2 from the right? Which is not what I wrote, but that would be this point here, wouldn't it? So what we're going to find is with limits, it doesn't matter if the point's open or closed, just so you approach it, right? So as I approach from the left, I'm approaching where y is equal to 0, correct? And as we approach from the right, we're approaching y equals 0. So both of these would be zeros. That's what I kind of meant to do that. Okay? Okay, so what we would like to find, and what we can find sometimes, once we have done the one-sided limits, right? Once we've done the left-hand limit and the right-hand limit for a certain x value, we can see if there's a two-sided limit. Okay, and the kind of rule for that is the two-sided limit is just x approaches a. It doesn't have a plus or a minus. It doesn't tell you from the left or from the right. It tells you just as it approaches it from either direction. So if the left-hand limit and the right-hand limit both equal the same number, then there will be a two-sided limit, and that will equal the same number. Okay, so in terms of our picture here, as we were just talking about, we said the limit as x approaches -2 from the left. What did we say that was? It was 0. Good. And then the limit as x approaches -2 from the right is 0. Those are the same, correct? So therefore, the limit as x approaches -2 of f of x is equal to 0. Okay, so if both the left and right hand limit match, then you do have a two-sided limit. Even though here it's actually undefined at 2, correct? There's still a limit. The limit is just as you approach that point. So that's going to be a lot of what we use to kind of do some calculus techniques, because we have to deal with these things that we want things to get infinitely close but never quite get there a lot. Question?
So if we're writing limits, do we have to still put the right limit and the left limit with the two-sided limit, like the one-sided? Do we have to state all 3 of those?
Probably for now it would be good exercise to state all 3. It just sort of depends what you're doing. A lot of times it really just depends whether you need to state them all or not. But yeah. And then just to compare here, if we look at 1, right, we had 1, the limit as x approaches 1 from the left, that was 4, wasn't it? And then the limit as x approaches 1 from the right is 1. So these are different, right? They're both defined. It has a left-hand limit. It has a right-hand limit, but they're not the same. So if that's the case, therefore, the limit as x approaches 1 of f of x does not exist. If the left and the right-hand limit don't match, then the two-sided limit does not exist. Okay, and with the notation, remember, left and right, you'll get that little negative or positive, like in the exponent position. If it's a two-sided, it's just going to have the x value there, as that works.